everyone. So today we'll talking about decision tree as part of supervised machine learning. So it is supervised machine learning algorithm that can be used for classification and regression. Classification for categorize, for example, to check if it's fit and fit, and regression if you have a continuous value like exam score or temperature. So it's worked by splitting the data into a smaller group based on certain conditions rules, eventually reaching predictions at the leaves of the tree. So imagine you need to predict if this person fit or not fit. So we have age less than 30, and this one is called the root node, the first one, and we have this branches is called yes and not. This is the result from the age. So if the person is less than 30, so if it's yes, that means we need to check the eating habit for it. If the person no, that means we need to check the exercise habit for that. And if the person eat a lot of pizza, that means if it's yes, that means it is unfit, and if it's no, that means it is fit. And if the person it is not exercise in the morning, that means it is unfit, and if it is exercise, that means it is fit. So this is how we predict in this is the flow chart. So we have the first one is called the root node, and this is the root node, and then we have the leaf, the last classifications for the leaf, and we have is this sub tree is dividing between them, and this is the branches. So how does decision tree work? First, choose the best features to split on. So the model, it will choose the independent variables from your column based on metrics, like if you're dealing with the classification, so he will use Gini impurity and entropy to select your independent variables. If you have a continuous value, so the model will choose mean square error to select your variables, and then he will divide your variables to subset based on the chosen feature. And when does is a stop? As a stop depend on this condition. All data in the node belong to the same class. Maximum tree depth is reached. Minimum number of sample per node is reached. Or no further information gain can be made. And then for predictions, if you have a classification, the leaf output, they give you the majority classes. And if you have a numerical data, so the leaf output gives you the average value. So imagine we need to predict the student final score based on the hours study and midterm. So we have the average. This is 157 is the average, average score for all the students. And the model at the beginning, he chose the independent variables hours, and he chose that because we're dealing with the numerical value, so depend on the mean square error. The one that gives you the least mean square error, so he chose this one. And then if the student study less than 10 hours, so the average value they will get roughly is between 39. And the model is stopping here because there is no further complexity from here, no further splitting. But if the student study more than 10 hours, then the model start give you 75 average, and that 75 average where the model start give you another variables, it's called midterm. So he add midterm because 75 average is he need to classify the 70 into more complex splitting, so he had the midterm based on this criteria. And then if it's yes, midterm he was the score less than 65, then the average is 70. But if the midterm was bigger than 65, then the midterm, the average will give 1882. So this is the decision tree how it works for classification and for tag. There is advantage and disadvantage of using that. You don't need to scale your feature. Nonlinear, or if you have nonlinear relationship, is perfect for that. Handle both numerical categories of data, but boring to overfit, so you have to be careful with your input data. And the greedy splitting, local based decision may not be a globally best, can be biased toward features with more categorized. So how is really work? First, the model will start give you dividing the node into region. So this one give you region 1, region 2, region 3, region 4, and then he will predict. He will start to predict, and for predicting, he will calculate the average mean. He will calculate the mean for each prediction, and after that, the goal is to minimize the RSS, and the goal is to find the mean square error. So to give you the mean square error, the difference between the tested and predicted is very low. So stopping criteria, when the model should be stopped, as we said, depend on the three criteria. If the model reach the minimum observation at internal node, so at your root node, the first one, if he reach the minimum number of observation, so you have the minimum number of observation, that means your model is not going to be split anymore. If we are in the child is where the leaf node, in the leaf node, if you reach the leaf node and your model reaching to the minimum number of observation, that will not going to be split. Or if you set your maximum depth, if I set my maximum depth to be 3 layers, and then when the model reaches the 3 layers, it's not going to change anymore. We will discuss the pruning after that. So the pruning is the process of reducing the size of decision tree by removing parts of the tree that do not provide significant power in the reduction target variables. So the pruning process reduce the size of the decision tree. If you have not for the tree, if that not providing significant information prediction, so they try to remove it. This will help us to reduce the overfitting and make the model simpler and more generalized. So the pruning principles is the same RSS we calculate, but what we just add the code. And in here we will find, in here we need to first upload our CSV file. My data is called movie CSV file, and you know how to upload your CSV file. We talk about that. Firstly, I'm going to check the summary. So if I run my movie data and the summary of that, I was going to run that. So when I run my movie data, I found I have NA value in here, and the time taken, that means I have an empty values. So I need to find this is missing value and follow with that to find your missing value. So you have to run your code. This code, this is movie time. So I have a movie time taken. Movie time taken is .na movie time taken. This will allow me this functions as a return all the vectors that is missing value from this vector, and then equal to mean movie time taken na.remove. So this one, it will make sure to remove all the missing value and then calculate the mean for that. And after that, if you run this code, so you will calculate the mean for missing value, and then if you check your missing value, this is how you check your missing value by this code. Run this one, so you can check this time taken is 0. So we have all 0 in our independent variables. This is before you start working. And then we need to sublet my movie data. I have to set seed, and we talk about that many times. So need to make just run it. And now we go to the fit our regression parameter. So we will use regression tree equal to. So you need to have two packages called rpart and rpart.plot. This is to run your decision tree. So my regression tree, it will be rpart. This is rpart functions formula equal to my formula equal to collection tilde select all. So this is the collection from my movie data. So if you check, I have this collection. This is my independent variables, and all the others are going to be my independent variables. So collections, my data equal to train. I split my data into train and test, and the control equal to rpart dot control, and I'm going to use the maximum depth in here. The maximum depth is equal to my maximum depth. It will be equal to 3. So I'm set only for 3 layers. Run that. Let's gonna plot my regression tree. So rpart dot plot my regression tree, and then box plate. That just give you the box plate is just for the color. So for example, if I need the color mine to be blue, I'm gonna say not blue, gray is better. And then I have to give him the digits equal to -3. So let's go and check. So if you see now, this is the this is the collection, my target variables, and then I set the maximum depth to be 3. That means I have 3 layers. This is 1, this is 2, this is 3. The first root is not counting, and that's why I use the digit as -3. It's for easy for me to interpret. For example, if I change it to this is digits equal to 0, so you can see now. That means it will be so hard to interpret that I have minus plus to the power plus a. That's why I use the -3, so it will be easy to check my data and easy to interpret that. So he's used the first variable is the budget, and then he add another variables is a trailer view, and then he add another marketing expense until he find, because I set the maximum at the 3 maximum depth, that's why he stop at the layer leaf node is the last layer 3, and he stop. So let's gonna check how was our test spread. So let's gonna see how our model work on test data. So we will predict, we use the predict. Our model is called registry, and my test data is called test, and then I use the type equal to vector, when that allow me to check my data. Okay, vector. This one allow me to check my data with the test. So if I go to the test data, I can see my predict in here. I can compare the predict with the collection. This is the real value, and this is the predicted value. This is the prediction on the test data, so you can check. For example, you have 44,000, we have only 45. We have 40,000, we have 44,000. So you can check the prediction with your real value. And if I need to calculate the mean square error for predict, for mean square error for regression here, I'm going to call it equal to, so mean, we have the test underscore and test, we have a predict. This is the predicted value minus the test $, the collection, and this is over the power, sorry for that, over the power 2. Close that. So give us the mean. So the mean square error for regression is like 70.33, is very big in here. It have to be very small to check your data. So this is the fits, how to fit your regression. Now let's gonna check our pruning. So I'm gonna bring, because it's gonna be so long, I'm gonna bring the pruning and we discuss about that in more details. So let's gonna check the pruning to remove the overfitting, and we control the, so instead we use, I'm gonna name the full tree model. It's called, we use the same rpart formula, collection data, my data from a train, control equal rpart control, but I'm gonna use the cb equal to 0. This is for the complexity, the control, the complexity equal to 0. So in here we not give the layers maximum to 3. That's gonna give the cb complexity equal to 0, and we check. So let's gonna run this one, and then let's gonna plot our full tree is the same rpart.plot full tree, and this is the box plate where you give the color. So this is a box plate equal to gray and the digits -3. So if you plot that, you will see the difference. Now you can see, check. Now we have a lot of complexity because we set the cb, the complexity, to equal to 0. We have more complexity. We now set it to be 3 to more complex one. So if we check this plot, the cb, so this is a plot cb full tree. We need to find the at which the cb, the complexity, we need to find the minimum error. So and then we run our model with the minimum cb. So we have the less error, and then we have the less error, so we have the best prediction values. So first we will have to find the min cb, the minimum cb. So the data is called full tree data, and within the full tree we have the cb table, which minimum, and we have free tree. There's a cb table, we have x error and cb data. So this is the x error within the cb table, and we have the cb, which have to be in capital. So if we run that, as we found the cb value, minimum cb is 0.0099. So we need to find the minimum cb that give us the minimum error, and then we run it, so you have the best fitting line for your model. So we find the min, and now let's gonna prune full tree. So we use the prune tree. This is equal to prune full tree with the cb equal to min cb value. And if we run this one, so this is the prune where he remove all the unnecessary splitting. If you have unnecessary splitting, he will remove them and will keep only, and also he will use the cb equal to minimum cb, so to get the best result. And then if you run this one, so just for bloating, so now you can see he remove all the complexity, and now we have the model is more. We have only only 3 layers, and these 3 layers will give us with simple complexity, so to remove overfitting and remove the noisy data. And if you need to check the prediction on unseen data, so you check same what we did, test auto prediction, predict the free for the full tree, and test and vector equal to vector. So you can check with your test in here, and you can calculate the mean r square for the same, this predicted minus the actual. And we can check the test for Prune. When we use the Prune, the same predict Prune tree test equal to type, and this is our test, our data and type equal to vector is the same. So if we run that and run them, if we go to the test value now, we will have this predict, and this is the Prune, This after we remove the all necessary subletting. So you can check with the collection. This is 40, for example, this is 45,000. So we have this is 44 with the Prune. When we find the minimum CB, is allow us to check he give us the best result closing to the predicted one, to the actual one. So this is 44 and here without with the follow tree give us only 31,000. We have 35 and we have 29. This is 35. This is 27. We have this is 35. So with the Prune, with the minimum finding the CB, the complexity, the control complexity, it will give you the minimum. It will allow you to give you the minimum error. So to base your fit. This is all you need to know about the decision tree. I hope this makes sense for you. And if you have any comment, please let me know. Please subscribe and leave me a comment if you have anything. Thank you for watching and see you in the next video.